Students, I hope you've been enjoying your snow days. Here is the lesson on 6.5. Please watch this before class on Friday, and I will see you then. Okay, we've been going through lots of different types of quadrilaterals in this chapter. And this chapter, remember, is on quadrilaterals. But there's still two more that we need to go through. And the first one is a trapezoid. Okay, a trapezoid is a quadrilateral with exactly one pair of parallel sides. So only one pair of the sides are parallel, not both. Okay, so you can add that to your definition sheet if you'd like. This is what a typical trapezoid looks like right here. And the sides that are parallel we refer to as bases, and the sides that are not parallel we refer to as legs. So we can get very specific about the different parts of a trapezoid. So again, the sides that are parallel, those are the sides that we refer to as the bases, and the sides that are not parallel we refer to as legs. There are also two pairs of base angles, angle A and angle B. That is one pair of base angles, and angle D and angle C is another pair of base angles. So there are two pairs of base angles. We refer to A and B as one set of base angles and D and C as one set of base angles. An isosceles trapezoid is a trapezoid with congruent legs. So it's possible to have a trapezoid that does not have congruent legs, but if the legs are congruent, if AD here is congruent to BC, then we call this an isosceles trapezoid. So this would be an isosceles trapezoid. Moving along. If a trapezoid is isosceles, then one thing that we know to be true is that each pair of base angles is congruent. So we're going to write that out. If AD is congruent to BC, then each pair of base angles is congruent. So what that means is, remember, A and B is one pair of base angles, so we say angle A is congruent to angle B, and also the other pair of base angles is congruent. Angle D is congruent to angle C. So if we have an isosceles trapezoid, then let's add these tick marks to our picture here. Then A and B are congruent. Those two angles are the same. And D and C are congruent. Those two angles have the same measure. Okay. Moving right along. In the same way, if a trapezoid has a pair of base angles congruent, then we know it's an isosceles trapezoid. So this is the same rule, but it's just backwards. So here, once again, if it's isosceles, we know the base angles are congruent. What this is saying is, if we know that in a trapezoid one pair of the base angles are congruent, then we can say for certain that it is isosceles, that the legs are congruent. Remember, the legs, we have to be very specific. The legs are the non-parallel sides in any trapezoid. All right, and let's keep going. Couple more rules about trapezoids here. A trapezoid is isosceles if and only if its diagonals are congruent. So in an isosceles trapezoid, remember, these diagonals don't have to be drawn for them to be here. I think this is something that was confusing a lot of you. Diagonals exist whether or not they're drawn, right? If I draw a rectangle like this, it's a poorly drawn rectangle, but you get the idea. That rectangle, even though they're not drawn, has diagonals, okay? So what this theorem is saying, theorem 6.16, is that any isosceles trapezoid, when the legs are congruent, the diagonals are congruent as well. All right. Okay, now here's the first kind of new thing in this section that will take a little bit of explaining. Sorry, I'm drinking my coffee. The mid-segment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of the bases. Okay, so this red line right here is what's called the mid-segment, and you should notice a few things about it right away. The first thing is what it says is it's parallel to each base. Okay, so we should add an arrow like these bases have, because it is parallel to them. What you'll also notice is that it perfectly splits each leg in half, because this is BY is congruent to YC. That means that Y is directly between BC. Y is the midpoint of BC. You could also say that XY bisects BC and XY bisects AD. Okay, so it's exactly halfway between the different base angles, and it's parallel to each base. And what else we know is exactly what this theorem says. What this theorem says is that its length, so we're going to write this out. Remember how we refer to the length of something is just by writing the 2 points. XY, the length of XY, that means the length of XY, equals 1/2 the sum of the lengths of the bases. Okay, well, the length of this base up here is just AB, and it says it's 1/2 the length of the sum, so we're adding, and this base down here is DC. Okay, so XY, this mid-segment in this trapezoid, is 1/2 the length of AB plus DC. We add the two bases together, multiply them by 1/2, or divide them by 2. Those are the same operation, dividing them by 2 or multiplying them by 1/2, and that will be the length of this mid-segment. Okay, what I have now is a slide of some example problems, and we're going to do this first one together. And then I would like you to do the rest on your own, and we will go over them in class. So this first one says find the measure of each angle. Okay, well, this one looks like it might be simple right off, but it's a little bit more complicated than at first glance. So if this is an isosceles trapezoid, which it says it is, then we know each set of base angles is congruent. So if this angle is 50, then we know this angle is 52. Now, we don't know what A and B are, but we know they're congruent. We also know that since it's a quadrilateral, all of the angles add up to 360. So what I'm going to do is I'm just going to add up all of these angles. So 50 plus 50 plus... Now, like I said, we don't know what these angles are, but since we know they're the same, if I use a variable for one, I should use the same variable for the other. So plus x equals 360, and now I need to solve this. Okay, so this is 100, so I need to subtract 100 from each side. I'm going to add these two x's together, so this becomes 2x equals 360 minus 100 is 260, and then I need to divide 260 by 2, and x is 130, which, remember, x is the same as angle B and angle D. Oh, I'm sorry, angle B and angle A. I'll just erase that really quickly. Okay, so there we found the measure of each angle there. What I want you to do is I want you to go ahead, do the same for this one. Use the mid-segment formula for this one to find the length of x. And then continue right along. So pause the video if you need to, go ahead and do those, and we'll check these first thing in class. Okay, the last type of quadrilateral that we're going to go through is something called a kite. And kites are easy to remember. They're four-sided shapes. It's a quadrilateral, but it's easy to remember because they look like kites. And A kite is defined as a quadrilateral that has two pairs of consecutive congruent sides, but opposite sides are not congruent. So what that is saying is it's a quadrilateral where the sides that are next to each other are congruent, and there's two pairs of them, not the sides opposite. So you'll notice by these tick marks, this side and this side is not, they are not congruent, but AB and BC are. That's what makes a kite, the fact that the two congruent sides are touching right there, and these two sides that are congruent are touching right there. So if the opposite sides are not congruent, what can a kite not be? You should be saying to yourself, okay, if the opposite sides are not congruent, then a kite cannot be a parallelogram. And that is in fact true. That if a kite can never be a parallelogram because the opposite sides can never be congruent. Okay, so that's a kite. That's an introduction to a kite. You can add that to your definition sheet if you want. We're going to learn a couple rules about kites really quickly. If a quadrilateral is a kite, I don't know why this is all jumbled up here. Well, bear with me. See if I can, there we go. If a quadrilateral is a kite, then its diagonals are perpendicular. Okay? So in every kite, the diagonals, which remember do not have to be drawn for them to be there, are perpendicular. Remember, what it means for two things to be perpendicular is that they intersect to form a right angle. So here's how we would draw that. We would say BD, line BD, is perpendicular to AC. Remember, that's how we say perpendicular. And to add that to our picture, all we would need to do is to draw a right angle right there. And us drawing a right angle right there implies that there's a right angle at all of these spots right here. Okay? So, in a kite, diagonals are always perpendicular. If a quadrilateral is a kite, then what else we know is that exactly one pair of opposite angles are congruent. So not two pairs are congruent, but exactly one pair. If you look at this picture, which two pairs of opposite angles does it look like are congruent? Well, here's one pair of opposite angles right there. Does it look like those are congruent? You should be saying to yourself, no, it does not look like they're congruent. In fact, it looks like they're probably a little bit different. But if I look at these pair of opposite angles, those do look like they're the same. And in fact, they are. So in every kite, there's exactly one pair of opposite angles that are congruent. And in this kite, it's angle A and angle C. All right? Okay, last thing. Here's what we have. We have a couple of practice problems. And I would like you to give these a try. I'll give you a hint for this one. This one is going to involve the most famous theorem that we talk about all the time. Hint, hint, the Pythagorean theorem. So you're going to have to use the Pythagorean theorem here. And this one is going to involve the theorem that we just learned. Okay, I hope you enjoyed this lesson. I hope you've been enjoying your snow days. Make sure you watch this before coming to class tomorrow. And I will see you soon. Thanks, guys.